according to this model, what is the absolute maximum amount of oil produced? Okay, so remember we have the same table, P of T, P prime, and then P of T that we've been using all the time, from 0 to 110, 0 representing 1910, and 110 is 110 years after 1000, the year 1910. Okay, so we have to find P prime. So I have to multiply this by 4. 3, and that's 7, and it's 8. Yes, 3, 7, and 8, correct. And still 7. 2, 4, 6, 7. T to the third minus 2, 18, 20, 4, 3 plus 2, 5, and still 4. And then T squared, and then plus 0.2. So this is 1 and 1, 2, 3, and 2 zeros. And then plus 0.002 T. And we want to determine the zeros. We have to set it equal to 0 and see what we get. So I'm going to share my screen and plug it in the graphing calculator. So here it is. In y equals, clear if you have anything else. And actually, let's do this. Go to apps and choose number 9. And then the degree is 3. And then the coefficients are 0, 1, 2, 3, 4, 5, 6, 7, 8, 7, 6. Then the next one is negative 0.1234501, and then the next one is 0.003110310, and the next one, last one is oh no, there is no T here, of course. I wrote the T again by mistake at the very end. I whited out. So 0.002. And then just solve. And we have 3 solutions. 501 does not fit. Negative 0.63 does not fit. So the only one is 71.33, which is 71 years since 1910. Okay, so this is 0. And now when I plug in 0, this is positive. And when I plug in 110, let me see if I plug in. I have to study the sign. So I study the sign here with 0 because this is positive. But I also have to study the sign here and just make sure that it's negative. But I cannot just fill it in before I check. So this will be 1,000, but this is so much smaller. This will be 100. Yes, it will be negative. You can check. Now, if we're asked, we're not, according to this model, what is the absolute maximum amount? Okay, so this will be the absolute maximum, which is P of 71.33. You just have to plug it in the function. So put the function in the graphing calculator and plug in 71.33, and you'll get this. And this is the absolute maximum. And then, according to this model, at what rate was United States oil production declining in 2010 and in 2015? So for 2010, you have to determine P prime of 2010 minus 19, so that's 100 years. And then the other one for 2015, and you have to plug in 105. And the measurement unit will have to be 2 measurement units, right? So so this is not in dollars, sorry. This is billions of barrels. So billions of barrels per year is going to be the measurement unit for these two. And that's all you need to do. So this is in year 1981. So what was difficult with this, or what was the problem? Anyone?
Yeah, I think just getting all of those zeros in there, it became very tedious. So
oh yeah. You have to be careful.
To go over.
Yes, of course. You have to be careful with entering the information. Yes. Mm-hmm. Yes, absolutely. Once you understand the mechanism, everything. If there is an error somewhere, it must be due to a typo or something. Good. Anything else? Anyone else? Other questions?
Yeah, I have a question. Although yes. We don't need to do the whole problem. Just if in a problem like that one, actually, well, 64 on the homework was what I was thinking of.
Yeah, let's take a look. What's 64 from what? I did not get the chance to write solutions yet.
I don't have the page number.
But tell me the section number. That's good enough.
2.4.
2.4. Okay, so let's look at 64 in 2.4. And that was
on page 242.
4x squared. Thank you so much. Is this the one?
Yes.
Okay, on the closed interval 0, 8. Yes, I'm ready.
Okay, so I don't really have an issue like going through the process. It's just when it gets to the answers, there's one absolute max that's also a relative max, but the minimums there's two different values on that interval. Actually, both 0 and
let's
8,
take a look.
Give you the same.
So if it created some issues, let's do it. Okay. So did I copy the problem correctly? Just making sure. This is power 3 and this is power 2, correct?
Correct.
Okay. So first of all, I'll get my table going. For something like this, just for the absolute max and min, I do not need the second derivative. One of you determined the oops, I didn't say when I say something, I write it, which was brilliant. One of you determined the maximum or the minimum using the second derivative. Way too much work. Brilliant, but way too much work. Will I really want to go and find the second derivative, which is so much more difficult than the first derivative, just to find the max of this function? I will never do it. But you're brave enough. I commend you. Very good. That's wonderful. Okay, so f prime of x. So I have 8x minus 3/2 x squared. When I set this equal to 0, obviously I would factor out x, so the first solution is 0. And the other one comes from 8 minus 3/2 x equals 0, right? I move 8 to the other side, so I have negative 3/2 x equals negative 8, multiply by 2, so I get 16/3. So x equals 16/3. So 0 is here, and then 16/3 is 5 and a little bit, right? So it's within the domain. That's all I was worried about. So 0. So this is quadratic. Always in between solutions is always the opposite of the leading coefficient. But please check. Don't just put some symbols in here. So if the leading coefficient is negative in between solutions, this must be positive. It's guaranteed. If it's quadratic. If it's not quadratic, no, you cannot conclude that. So now I have to plug in the function these 3 x values. Okay, Okay, now if it happens that I get here the same answer, which is very possible, then I have two absolute min. And this is definitely the absolute max, no question asked. And
that
local.
Was my question is like, do we
Yes, I have to consider
two absolutes,
yes,
or just
yes,
okay.
Yes. So it has if this and this are the same, then I would say the function has absolute min at x equals 0 and x equals 8, and an absolute max at 18 divided by 3. So I will write this and this, if that's the case, as the absolute min. Now, if one is lower, then that will be the absolute min, and the other one will be nothing. And the 16/3, comma, I didn't mean that, comma, whatever, it will be the absolute max. Yes, a function can have many absolute max, absolute min, as long as they are the same y value. Do I have to determine these values?
No, that's
okay.
That's fine.
Perfect questions. Thank you. Anything else? Is there anything else that you would like to go back to? Okay, on the same note, 2.5, more applications. The same thing, the same kind. Maybe not on a closed interval, but the same type of max-min situations. So I'm going to share my screen and go to the book. I think I had it up here, yes, in 2.5, in which we find max-min. Of course, the critical number, of course, the derivative, of course, studying the sign of the derivative. And if you're brave enough to go to the second derivative, I am super happy, but you're working way too hard. Okay, where is my navigation? And I want 255. If I find my keyboard. I did. Okay. So we can talk about maximizing profit, surface area. So I like to look at two problems. Something with cost, profit, revenue, and maybe some other problem. I don't know, maximizing cost for a box. This is maximizing cost, minimizing cost. I meant to say minimizing cost, maximizing revenue, maximizing profit.
Can we do one of the minimizing costs?
Yes.
39.
Okay, let's read 39. A rectangular parking area measuring 5,000 square feet is to be enclosed on 3 sides using chain link fencing that costs $4.50 per foot. So the area is 5,000, and just 3 sides will have fencing. Okay, so that's on page 256. So I'm just going to write something like this. I'm just going to graph something, a picture, and then I'll stop sharing. Okay. So this is 5,000 square feet, and it's rectangular. So I'm going to say this is X and this is Y. On 3 sides, and it's $4.50 per foot. Okay. The 4th side will be a wooded fence that costs, okay. So then this side is $7 per foot. Okay. What dimensions will minimize the total cost to enclose this area? And what is the minimum cost? Excellent problem. Okay. So now let me stop sharing. I may have to go back again just to make sure. So we have a parking lot, and we know that the area is 5,000 square feet. On 3 sides, we want to put a fence that is metal fence, and it costs $4.50 per foot. The front side It will also be fenced, but it will have a wood fence, and this is more expensive than the metal, according to the problem. It's $7 per foot. So we want to minimize our cost. What should the dimensions be? In the width or the length, it doesn't matter, width and length. Okay, so one more time, let's go back just to read one problem one more time just to make sure. Rectangular parking area measuring this is to be enclosed on 3 sides by, okay, what dimensions, what length, and what width will minimize the total cost to enclose this area? And what is the minimum cost? Perfect. So this area of mathematics is called optimization. It's a huge field. One variable or even more than one, multivariable also. It's as big as trigonometry, algebra, you name it. Optimization deals with finding max-min for all sorts of functions. There are a lot of courses even at the 600 level. Universities have courses in optimization. Okay. Now, we have to create a function. This is step number 1. I have to find a function. In step number 2, I will find whatever I'm asked. In this case, I'm asked to find its minimum. If I don't have the function, I will not be able to find the minimum. So first, I focus myself on finding a function, and then the rest is easy because I know how to find the minimum. Find critical numbers, study the sign of the derivative, put in the table, and I'm done. So the difficult part here is, if you want to say difficult, but